Okay, before we actually get to that definition, though, we want to label what a matrix is. Okay, and a matrix is labeled in the number of columns and the number of rows it actually has. Okay, and it's always in this format: rows x columns. Right. So, for example, it'd be like 2, 3. This is saying a 2 by 3 matrix when it comes to it. Okay, so let's say, for example, I have something like this. And I asked you, okay, what is this? How do I say? Define this matrix. So it always goes rows by columns. So how many rows we have? So it's 2 by, and then how many columns? So 1, 2, 3, 4. So this is a 2 by 4 matrix. And again, we keep going and going and going, right, when it comes to it. So here's another example. This is actually a trick example. There. So if I again ask you to define this matrix, this is a 1, 2, 3, 3 by 1 column. Right, because there's technically 3 rows, 1, 2, 3, and only 1 column. On the contrary, we can also have some like this. This is kind of trick questions. This would be 1 row by 1, 2, 3, 4 columns. So that's how we label a matrix, depending on how many rows and columns. And again, it's always rows first, then the columns. So just be very careful about that. All right. Okay, so now that we know how to define what a matrix is, right? State how many columns, how many rows, and state how it is like this. Now let's actually talk about the determinant of a matrix. Okay, so first definition is determinant of a matrix is denoted as D a T with parentheses A in it. Okay. Now, this could be a little differently in your book. I truly don't like how it's defined in your book. So I'm always going to label it like this. Okay. So DET stands for determinant, and then A is the matrix A we'll talk about in a little bit. Okay. So I just like that notation because I was actually brought up on that. Your book gives you this. It's called like this. I think that's what they do it. I don't like that because if you go into higher math, that signifies something drastically different than that. So I'd rather just give it to you like this and I think it makes more sense, right? The determinant is just short for DET. And the matrix A is what's the matrix we're looking for itself. Okay. So that's just the reason why. Okay. So we're going to find this determinant and we're going to use this to solve for a system of equations. Okay. Now, to find the determinant of a 2 by 2 matrix, so remember, a 2 by 2 means it's 2 columns and 2 rows. So essentially like this. So we'll call matrix A is denoted as this whole thing here. Okay. So the determinant of this matrix is the multiplication of A times D minus the multiplication of C times B. So you can kind of think of you're multiplying the diagonals together and then subtracting them. That's essentially the determinant of a matrix. Okay. And it's just a single number that defines the matrix. And again, if you're wondering why that we care about that, just give it some time and you'll figure out as to why we care about finding the determinant of a matrix. Okay. And that's it. And the key thing is it has to be a 2 by 2 matrix. This is the only way to find the determinant. So in other words, we can't do this one, this one, this one. It has to be a 2 by 2, or whatever they call it, an n by n. We'll talk about that also in a little bit as well. Okay. So let's just do some practice, right? Finding determinants of some matrices here. Okay. So let's find the determinant of matrix A here. Okay. So according to our equation, it's going to be this number times that number. So 10 times 5 minus the multiplication of this and that. So -4 times 6. And now we just do order operations, right? First multiply, it gives you 50. This gives you -24. So we'll end up adding. So 50 plus 24 gives you the answer. So that's going to be 74. So 74 is the determinant of this matrix here. Any questions on our first example? Okay. So let's keep going. Just do some more. So this times that, so it's going to be 3 times -4 minus 0 times 7. So this just ends up being 0. So this is just -12. So our answer is -12. Right. Next one. So same thing. -3 times 4 minus 20 times 17. So this is going to be -12 minus, what is that? 34? Is that 340? I think. Yeah, 340. And then subtract. So -352. There we go. Okay. Now the cool thing is we can go way back and do the first thing we did, right, with imaginary numbers. So it just always have to be just single numbers. Now we can just plug in the imaginary numbers or even letters when it comes to f. So let's find the determinant of x here. So same process. It's going to be I times 4 minus 6i times 6. So this is just 4i. This is going to be 36i. Right? And then collect on like terms gives you -32i. There we go. Right. And then the last one here is, so multiply, so a times 5b minus 6a times b. So this is just 5ab minus 6ab. So it's going to be negative ab, right? Once you add them together. Questions there at all on finding the determinant of a 2 by 2 matrix? All good? So far easier than the last section, I'm hoping. Okay. All right. Now, what if we want to go higher? What if it's a 3 by 3 matrix or a 4 by 4 matrix or a 5 by 5, right? So we're not going to get that much because after 3 it just gets kind of ridiculous. But for a 3 by 3 matrix, so 3 rows and 3 columns, it looks like this. Our determinant is not as easy as the last one. It's actually broken down into 3 separate determinants when it comes to it, okay? Looking like this. Right? So the defined determinant of a 3 by 3 matrix, first thing is these top numbers, A, B, and C, are to be multiplied there. Okay. Now the first determinant is going to be, if I just get rid of this row and cross these numbers out, I'll get a 2 by 2 matrix here. That's where it goes there. The middle one is, again, what if I cross B out completely? I'll have D, F, G, I left over, and that's what you put here. And the last one is, again, if this one's crossed out, you'll do D, E, G, H, and that's what's left over there. Now, it's a little bit more complicated than the last one, right? Hence, no one does higher than 3 by 3 because it just gets super, super ridiculous. Okay? Now, also, the format is always plus, minus, plus. Okay? So meaning the middle one is always going to be minusing here. So just be very careful. So this B is always going to be a negative in front of it when we do this evaluation. Okay. But again, the hardest work is just slowly breaking it down. At that point, the determinant is actually not as bad to do. We're just going to go back and do the same thing we did in the last couple examples. Okay. So let's find this one out. So here's an example of step-by-step how we do it. So here is a 3 by 3 matrix. Right? So meaning these 3 numbers are A, B, and C. So there's our A, our B, right, with the negative, and our C. Okay. Now remember, to find this first matrix here is if I cover the 2 up, notice I have these 4 numbers. That exactly goes there. Okay. In the middle, if I cover the middle up completely, I have those 4 numbers, again, in the order in which you see them. And then if I cover the 12 up, again, I have those 4 numbers go there. So everybody see where they're all going when it comes to it? And then at this point, we find the determinant 3 times. 1, 2, 3, and just slowly simplify as best we can. So find the determinant, negative 6 times 5, minus 4 times 7, 3 times 5, times negative 2 times 7, 3 times 4, minus negative 2 times negative 6. Right, and all we do is just going to multiply the results on the outside. So we're literally doing the determinant of a 2 by 2 3 times when it comes to a 3 by 3 matrix. But again, the whole work is just setting up the process there. Okay. All right, so now that we set it up, now let's find the determinant of each one. So we're just going to slowly simplify this, right? So it's going to be 2 times something. So this is going to be negative 30 minus 28, just from here, plus 4 times, this is 15, minus a negative 14, plus 12 times, this is 12, minus, this is going to be positive, so positive 12. Okay, so 2 times, this is going to be a big number, right? Yeah, negative 58, plus 4 times, this is positive, so this will be 29, plus 12 times, oh, that's nice, that's 0. Right? Comes to it. And then now, multiplying this out gives you negative 116 plus, I don't know what that is, 116. Oh, look at that, gives you a fat 0. So the determinant of this matrix is 0. So all that work for big fat 0. So a little bit more work to find the determinant of a 3 by 3 matrix when it comes to it. Right. So let's try an example completely out, using this as our template here. Okay. All right, let's see. So remember, the top numbers are what's being multiplied. So we're going to have negative 2 times some determinant of this matrix minus a negative 4 times some matrix, and then plus 2 times some matrix. Okay. All right, so first the negative 2. So I'm going to cover up where the 2 is. Again, you see those 4 numbers. So 6, negative 2, 0, and 1. Right, those are the only numbers that are not covered or encircled. Right, negative 4 is in the middle. So those are our next 4 numbers that are split. So 4, negative 2, negative 1, and 1. And then the 2 are those 4 numbers. So 4, 6, negative 1, and 0. So again, any questions on just how the setup is so far? Is everybody good so far? All right, and now we find the determinant of each one individually. So it's going to be negative 2, right? 6 times 1 is 6, minus 0 times negative 2 is 0. That's super nice, right? This ends up being positive 4. Okay. 4 times 1 is just 4. Minus negative 1 times negative 2 is positive 2. Okay. 4 times 0 is 0. -1 times 6 is -6. So we get that. It's not too bad. And now simplify it. So -2 times 6 is going to be 4 times 2. And this is going to be 2 times negative makes positive 6 there. Right, so it'll be -12 plus 8 plus 12, which gives you a grand total of 8. Okay. So, any questions on our determinant of a 3 by 3 matrix? Everybody good? Good. So why do we care about this stuff? Why do we care about finding the determinant? Well, like I said, math people, when it comes to something new, is like Christmas, right? They want to do something, want to use it, and want to do everything with it. So we're going to go into our second way of solving for a system of equation. It's called Cramer's rule. So Cramer's rule for two variables says, if I have a system of equations just like this, so instead of using matrices, this is an alternative to that. Okay? So using this format is now I'm going to find the determinants of a couple matrices and then just simply divide them. And we're actually done. That gives you the x value and the y value automatically. Okay? How this works is we're going to first construct 3 different matrices and then find the determinant of all 3. Okay? So first one we're going to call matrix D is just going to be the letters A, B, C, D. In other words, just the variable ones involved. So in other words, just those 4 there. Okay. Next one is called the matrix DX. So matrix DX means is instead of A and D with the X values, I'm going to replace them with C and F instead and keep the Y's themselves. So that's how we define DX. So DX means I'm replacing the X variables with what they're equal to. And the same thing applies for dy. So dy says I'm replacing the y variables with what they're equal to there. Okay. And it's kind of funky, but it does actually work out. It's pretty crazy how they learned how to do this because way back in the day. Okay. So again, I'll talk about it. So d is just x and y variables, just like regular old ones. dx means I'm replacing the x variables to what they're equal to. And dy is just the opposite. I'm replacing the y values with what they're equal to there. Okay. So next up, once we define these 3, is I'm going to find the determinant of each matrix itself. So right, 2 by 2. So just cross multiply and subtract, cross multiply and subtract. And then what I'm going to do with it is I'm going to divide the dx divided by the d, and the dy divided by d, and that is your x and y respectively. Pretty crazy, huh? So in other words, all we have to do is find 3 matrices, 3 determinants, divide the determinants individually, and you get your x and y there. So again, this is an alternative if you hate matrices format to do this kind of stuff as well. So let's do an example so you can see how exactly this is going to work out accordingly. Okay. So let's solve using Cramer's rule. So this is Cramer's rule here. Okay. So here's our system. So first up, we define what D is. So D is, remember, is just the x and y's respectively. So it's 3, -4, 5, and 2. Right there. That's your D. And then the dx means instead of these ones, I'm going to put these ones instead. So that's why there's a 1 and 19, and the y stay the same. Now, so the opposite for dy. So I'm just going to replace the y's with 1 and 19. So that's why they're there, 1 and 19. And the x's now stay the same, 3 and 5. Okay. So that's how you define d, dx, and y. Okay. Any questions there? Okay. And now we just find the determinant of each one individually, right? So in other words, 3 times 2 minus 5 times -4. And that's what we just did here. So this gives you 26. Determinant of this one, just again, right, multiply and subtract, gives you 78, And same thing, multiply and subtract gives you 52, just like we did above. Okay. Now to find the x value, it's going to be the dx divided by d. So in other words, 78 divided by 26 gives you 3. And then to find y, it's a dy. So 52 divided by the 26 gives you 2. So therefore, x is going to be 3 and y is going to be 2. Again, it's just an alternative to solve for a system of equations using matrices. Instead of row reduction, this is another way using its determinant of the matrix. So any questions on our example here so far? No? All good so far? All right, in that case, let's actually try a couple out. Okay, so let's solve using Cramer's rule, meaning we have to first set up our 3 matrices and then go from there. Okay. All right. So D is just the x and y, so it's going to be 3, 2, 2, and negative 1. Right? So it's going to be 3, 2, 2, negative 1. The x means now I'm going to put these instead, so it'd be negative 4, negative 5, and then the y's, 2 and negative 1. And then dy is the opposite. So now the x's stay the same, but the y's are now going to be negative 4 and negative 5. So just be very careful how you define these two. All right, next up we find the determinant of each one. So the determinant of D is going to be 3 times negative 1, which is just negative 3, minus 2 times 2 is 4. So that's just going to be negative 7. Right. Find the determinant of dx. So it's negative 4 times negative 1, so that's positive 4, minus negative 5 times 2 is negative 10. Right. So this ends up being positive, so it's going to be positive 14. And then the last one, the same thing, determinant of dy. 5 times negative 3, or sorry, 3 times negative 5 is negative 15. And then 2 times negative 8, what am I saying? 2 times negative 4 is negative 8. You see that? So this ends up being adding. So I think that gives you negative 7 when it comes to it. All right, so now that we determinants of each one, so x is going to be dx, 14, divided by d, which is negative 7. And y is going to be dy, which is negative 7, divided by d. So look at that. That's why some things this is pretty nicely, because it's a little less work when it comes to it. And look at that. We got our x and y respectively. Questions here at all? Everybody comfortable? Okay. All right, let's try another one. So same thing. We got to define our d, dx, and then dy. Oh, no, it's 3 times negative 1. That's a negative 3. So it's a negative 3 there, if that's what you're asking. Yeah, so be careful, yeah. Okay. So if we define it, so 4, negative 1, 2, and 3. Right, just follow the same pattern we did on top. All right, dx is x has now become 0 and 14. y stay the same, so -1, 3. And then lastly, do y, x's stay the same, but now the y's are 0 and 14. All right, same thing. Now let's find the determinant of each one. So 4 times 3 is 12, minus 2 times -1 is -2. So that's adding, so that's going to give you 14. Determinant of dx would be 0 times 3 is 0, minus 14 times -1 is -14. So again, that's adding, so that's going to give you another 14 there. And then lastly, 4 times 14, which I don't know what that is, 56, minus 0, so that's just 56. All right, so now we know x. So the value of x is going to be dx, which was 14, over d, which is just 14 as well. And then the y is going to be dy, which is 56, divided by 14, which is d again. And this is going to be 1 and 4. There are your answers there. Do you guys prefer this better than the matrices? Probably, right? So yeah. Yes, yeah. This is probably a lot of kids' favorites than matrices. But matrices is actually pretty cool. The reason why matrices is also used as well as like, well, why don't you just always use this is because once you get to like 3x3s and 4x4s, this is like a whole hectic, and it's just easier to do row reduction, believe it or not. When I was in linear algebra, which is application of this, one question actually took a whole page up, and it just row reduction, because if you would have actually done it this way, it would have been twice as long. So it really just depends on some of the questions. So we're just doing 2 variables, but we do 3 variables, right? And like we're in 3 dimensions, so it gets a little bit complicated when it comes to it. But yeah, so for now, this is kind of nice and the preferred method for a lot of people, anyways, as well. All right, so let's do our last example here. So same thing, using Cramer's rule. So we need d, dx, and dy. All right, so d is going to be 5, 7, 6, and 8. Dx is going to be -1, 1, 7, and 8. And then dy is going to be 5, 6 down here, and then -1, 1 there. Right? Comes to it. All right, so last one. Find x and y. Go for it. Ooh, are you guys sure? Got something a lot different than that. Give you guys another 30, 40 seconds to try it out. Okay, let's see if you guys are all right. I got something different. We'll find out. Let's see. The determinant of D is 5 times 8 is what's 40, minus 6 times 7 is 42. That's going to be negative 2. Determinant of dx is negative 1 times 8, so that's negative 8, minus 1 times 7, which is 7, so that's negative 15. And the determinant of dy is 5 times 1 is 5, minus 6 times negative 1 is negative 6. So that gives you 11. So x is going to be negative 15 over negative 2. And y is going to be 11 over negative 2. Oh, looks like you guys were right. There you go. So even here, you can have fractions. Good job. All right, so any questions on finding determinants, Cramer rule, anything like this?